All right, so couple things off the top. Before you talk, less time we have to cover things. All right, so what was due on last Friday? Yeah, so not ignoring emails. I got a bit of a backlog. It was a fall break. I will respond to them. But if you're telling me that you missed the due date, when it comes to these assignments, I know I mentioned it multiple times last class that pack assignment was due, right? And the due date set's kind of on there in Canvas. Part of being in college is keeping up to due date. Keeping track of the due dates across multiple classes. Right, part of it is from learning how to time management. And so I can't make exceptions for one person because they missed a due date and not make it for everybody else. Otherwise, it's kind of unfair to everybody else who got it on time. Okay. So I'll respond to those emails, but if you sent me a handful of those, there's a handful of them, they're still sitting in my inbox. I'm still kind of working back to them. And kind of the due dates we had set are kind of hard and fast due dates, right? So you need to get things submitted before that due date passes. Okay. Another thing that I feel like I'm going crazy, but my other section solidified I'm not. When I show you these questions in class, answering questions in class does what? Absolutely nothing, right? In fact, I've got a way I think I'm going to safeguard from this, where it's not even going to show you the questions on your Top Hat account from now on, because I'm getting too many people who say I was in class and I answer them and I say, okay, what do I say you still need to do? Still need to get on after class and answer the questions in the assignment that's posted. The in-class questions are just for us to cover them. So if you are in class, it's easy to get full credit on those questions, right? So from now on, I'll just make it so I can present it in a way that you can't actually respond in class. So the only way you're earning questions for those class questions are if you get on after class and answer them, okay? So moving forward, I'll do it that way so you can't even see the questions in class pop up on your account. Maybe that'll kind of help with some of that confusion. I feel like I've said this a couple times, but that's how it's going to be moving forward. Okay. Is there anything else I wanted to mention? Oh, so I'll post this in an announcement. My office hours this week. Usually they will be tomorrow. I think I mentioned this last week, but I have another class where I have a couple sections that has an exam on Thursday. So just like when you guys had an exam, I told them not to show up to office hours the day before. I'm not going to have office hours for you guys the day before, so I can make sure I'm getting their questions answered for their exam. I will move those office hours to Friday in the same kind of time slot. So in the announcement, I'll reiterate this, but 12:30 to 3:30 office hours will be Friday this week. Okay. Other than that, I think that covers kind of the housekeeping stuff for me off the top. I also put an announcement early this morning. Started to get a couple people that panicked. I had to change some things on the back end so that module 8 reading was scored 4 out of 4. Just had to kind of scale it based off of your responses. It originally had like 7 questions on there. It was only giving you credit for 6 because some of them were participation. I had to go through and give everyone just a full point if they answered that question. It should now be scaled on Top Hat and Canvas that if you answered every single question, you got it correct. You should see the 4 out of 4 there now showing up. Okay, so there's a little bit of a buffer on that. Delay on that. I got that switched over before we started class. So hopefully not too many people even notice anything was going on, right? Right now, if you go on, it'll look like 4 out of 4, everything's fine, okay? Other than that, any questions for me before we jump into this week's material? Okay, so we've got this week, next week, and then following week will be exam number 2, right? So things start moving quick once we get into the semester, right? We've already covered, I would argue, those last 2 modules in it quite a bit harder than the first 4. It's up to you. That's my preference. I don't know what you guys think. I think it's a little bit harder. We're going to dive in deeper now this week into consumer topics, and then next week, firm-specific topics. So we're kind of moving away from looking at the market as a whole and really like focusing on just consumers, and then next week we'll be focusing on just firms, okay? So even though it's new stuff, we can relate it to a lot of the old stuff that we've looked at. So, excuse me. What we're going to start out with this week is what I'm going to start calling a budget line. I think this will make a little bit more sense as we kind of work through this. So let's start simple, just two goods. You go to the store and you're deciding between buying two different goods. You can have different combinations of these two goods. How much can you afford? All right. Well, how much does the X good cost you times however many you buy, plus however much the Y good costs you times however many you're buying. You can only buy up to however much income you have. Now, there's different combinations. So this is what we call our budget constraint. And I'll throw some example numbers in there as we kind of work through this first example. But I can buy any two combinations of these goods. So I can only buy X or I can only buy Y. And if I do that, I can afford a certain amount. But I don't just have to buy one type of good. You know, all of us buy multiple types of goods at the same time. Here, we're just going to kind of keep it simple with two different goods. Okay. So if these were my prices, and I'm thinking about what combinations of these two goods result in me spending all of my income. Okay. So I have kind of the price of this X-axis good. Oh. That's a little better. Was what, $2. Price of my Y-axis good was 5, and the total income I had was 40. So if I'm thinking about, I have different combinations of this X and Y good that I can buy. If I'm only buying good Y, how much could I afford here? If I've got $40, each unit costs me $5. Yeah, what did you do there? You took the total amount of income you had and you divide it by the price of that good. So this would be what? 40 over 5, or this is a 4, sorry, or 8, right? But what if I'm only buying the X-axis good, right? None of the Y-axis good. How much could I afford? What did you do there? You took your total amount of income, divided by the price of that good. If you're only buying X, you could afford to buy 20 units. Now, we know that in practice, you don't just buy one type of good. You might want to have a different combination of these two goods. So for example, like I could buy what? 4 of good Y, in which case, if I think about my budget, oops, I'm mixing things up here. Here's my Y, here's my X, right? If I buy, oh, what did I want? I wanted 4 of the Y good, and the X good, let's say I'm buying 10. What's the total amount of money I've spent? 2 times 10 plus 5 times 40, I've spent all $40, right? So that point of 5 of the Y good, 10 of the X good, that's going to be a point on what we call our budget constraint, right? And there's a bunch of other combinations I can buy as well. What does this kind of look like? Yeah, PPC, right? We're now not talking about production decisions. We're talking about consumption decisions. So instead of being like the production possibilities curve, this is like my consumption possibilities curve. Now, we don't usually call it that, but just to kind of relate to things we've talked about, this is essentially all the different combinations using all of my resources, all of my income. These are the different combinations of the two goods that I could afford to buy, right? This is the maximum amount I could afford to buy, and I'd be using all of my income. So what would be true about points underneath this curve? Inefficient, or what would that mean in the context of a consumer? That would mean that, well, if I could buy 8, and I'm only buying like 4, what do I have left over? I've got income left over, right? So all these points are going to be affordable, but as we would kind of say with the production possibilities, it's inefficient. I'm not using all of my resources to buy these two goods. Okay? Now, what if I'm thinking about points that are out here? Well, if I can only buy 20 of the X-axis good, if I'm only buying it, how could I buy 20 and then also some of Y? Here, this would be a point that it's what? Yeah, so before we said unattainable, now we would probably say in the context of consumers, unaffordable. I don't have enough resources to get out to that consumption point. We'll eventually call that a consumption bundle, but it's a different combination of these two goods that we could buy. Okay. Questions on this before we keep moving? So I'm going to jump the gun a little bit, but I think it helps maybe to have like a full picture before we even get to talking about it. If I think about this curve or this budget constraint, if I start out, and here was what we said our budget constraint was. The total amount of money we were spending on Y plus the total amount of money we were spending on good X. That had to add up. If we were on that budget constraint, that added up to my total income. I'm spending all of my money. So how could I come up with an equation that would give me this line? Well, what's the equation of a line? Y equals mx plus b. What is my Y here? Just the quantity of Y. So I'm going to try to solve this equation for the quantity of Y. So I'm going to move this over. I've now got what? Negative, m minus px qx is equal to py qy. Divide both sides by the price of Y. Just rewrite this in a slightly different order. I now have, where does my line start? Well, it starts at the intercept where I'm only buying good Y. How do we say we determine that? We just take the total amount of income divided by the price of Y. The slope we're going to end up seeing ends up being the relative price of good X compared to good Y. Now, we'll put some other examples to this. I think it'll make it a little bit easier to math. But the slope of this budget constraint will always be the relative price of good X compared to good Y, or the price of good X over the price of good Y. So we'll use this here in a little bit, but just kind of setting up where that would come from. We're just rearranging this budget constraint formula so that we have our Y variable as a function of our X variable. Now, what do you notice we've got here? It's that relative price. Prices have to be positive, right? So what's the slope of my budget constraint always going to be? Got a negative sign there. Well, why? If I want to buy, if I'm spending all of my money here, if I want to buy more of good X, inherently, what do I have to do? If I'm only buying good Y here, spending all my money. If I want to buy some good X, I got to stop spending as much on good Y. There's this trade-off between the two. Just like when we're making production decisions, I'm using all of my resources at this point. If I want to get more of good X, I have to start giving up the production of good Y. Here, I have to start giving up the consumption of good Y. So pretty similar to what we were talking about, just in the context of consumers now. Okay. So I probably have already said some of this, but we'll kind of go through. I will always keep the examples here where slope is linear. Now, this isn't like a crazy assumption because I already told you the slope is the price of good X over the price of good Y. If you go to the store, if you buy more of good X, what happens to its price? You go to the gas station, you're buying candy bars and, I don't know, energy drinks. You start buying more candy bars, fewer energy drinks. What happens to the price of candy bars? When you're in the store and you decide you want 5, nothing happens, right? You're one consumer. You don't have enough power to move the entire demand curve, right? And of the moment, the prices are what they are. So when you're choosing this different combination of these two goods, that slope will always be the same, okay? So it'll always be linear, like that we kind of solved there. Now, we already talked about why it's negative. If I want to buy more of one good, I inherently have to buy less of the other. And then we already talked about those affordability points, right? Anything underneath my budget constraint, we said is affordable, but not efficient. I'm not using all of my income. Not today, I don't think, but next class, I'll kind of even allude to. Some people will sometimes give me pushback at this point and say, what? Well, why might I not want to spend all my income? I want to save. We can actually model at any point, we can view savings as its own good. And you don't just want to have income lying around because what can you do if it's, instead of collecting dust in a shoebox, you can invest it in things. So we always have the choice if we want to use all of our income, at the very least, on these savings goods. We'll think more about that next class, but I sometimes get pushback here. But ultimately, we want to be using all of our income, right? Even if that is on savings goods. We then said any point that's on that line, we're spending all of our money. We're using all of our income to buy these two goods. And any point past that budget constraint, we can't afford those points. Right? So we kind of already built all this out. So I've got a slightly different example. Well, we can kind of walk through it here. I think hopefully we can move through it a little bit quicker since we now have already went through one. So let's say I'm trying to change my image and I've got what? I'm only buying PBR and flannel shirts. I've got the prices of both goods. I've got my income is $200. And I'm telling you to put flannel shirts on our x-axis here. Okay. Well, the slides work through how we would do it if we put flannel shirts on the x-axis. I'll start out with that, but then also show you we don't have to necessarily do that. So we had flannel shirts cost 20. These cans of PBR cost 5, and my total income was 200. I said, let's put flannel shirts on my x-axis, and we'll put PBR up here. So if I'm only buying cans of PBR, how many total can I buy? So I've got $200. Each one costs me 5. 200 over 5 gives me that extreme point or that intercept of 40. We kind of think about, well, what would we have had? We have our Y good. We use that equation we had before. Was going to be our income over the price of that Y good minus the price of our X good over the price of our Y good times the quantity of our X good. I'm just kind of rewriting that equation in the context of our example. Now, we don't have to have this every time because notice I can say, oh, what would the intercept have to be if I'm only buying the Y-axis good? Income over the price of that Y-axis good. That's what this would be telling me too. What would my intercept be here? 200 over 5. My intercept, that Y-intercept is 40. I already found that. Just two different ways of thinking about the same thing. If I'm only buying my X-axis good, how much total can I afford? I got $200. Each one cost me 20. Yeah, 200 over 20 would give me 10. Now, I could already determine just based off the prices what the slope of that budget constraint could be. But let's for a second say, I didn't tell you this, right? And you didn't know that. How would you find the slope of this line? Yeah, just the change in Y over the change in X. What would the change in Y be? You're going from 40 to 0. X, you're going from 0 to 10. Or you get this slope of -4. Now think about what that means for us here in a second, but just to kind of make this connection, if I had just plugged in my relative prices, what slope would I have found? Price of a flannel shirt was 20. PBR was 5. Notice I would have found that same slope of -4. Okay. So what is this telling me? All right. It's very similar to the production possibilities curve. The slope is telling me that if I want one more unit of that X good, how many of the Y-axis goods am I, or how many units am I going to have to give up? So this is literally the cost of my X-axis good. It's exactly what we did with the production possibilities curve. So every one flannel shirt here is going to cost me 4 cans of PBR. Now I can kind of think about why and why the relative prices would give me that same cost. If I want to get one more flannel shirt and it costs me $20, how many cans of PBR would equate to $20? Well, if each one costs 5, 4, right? That's where that cost is coming from. It's just that relative price. If I want to buy one more of the X-axis good, it's however many times the price of that Y-axis good goes into the X-axis good, right? So if I want to get one more flannel shirt, it's going to cost me $20. So I got to spend $20 less on my Y-axis good PBR. What would $20 less be? 4 units. So that cost, or the slope of our budget constraint, is the cost of our X-axis good in terms of the other good, right? To get one more flannel shirt, I'm giving up 4 of that Y-axis good, or 4 cans, sorry, I said 5, 4 cans of PBR there. Okay. Any questions on this before we keep moving? So before I build this out for us, what if I wanted the cost of one more can of PBR? Well, if I know the cost of my X-axis good, how can I find the cost of my Y-axis good? We don't remember this? It's simply 1 over the slope. So here the cost would be what? Negative 1/4, or every can of PBR would cost me 1/4 of the flannel shirt. So we can think about how could I get that, building out an entire model here. Whoops. If I wanted to, I don't really have to. I can always do the same thing as I was doing with the production possibilities curve to find that cost of my y-axis good. What if I just flip the axis here? So what if I put PBR on my x-axis, flannel shirts up here? If I'm only buying flannel shirts, how many can I buy? 10. If I'm only buying PBR, how much can I buy? 40? Well, if I want to just do it using my quantities, change in y over change in x, I would have, sure enough, find that same cost of 1/4 as if I just took the inverse from my earlier one. Okay? So I can go ahead and rework this by flipping the axis and redoing everything, but I don't have to, right? And use those same principles that we had talked about before. Any questions on this idea? So if I'm now writing out my budget constraint with this, flannel shirts as my y-axis good, I could kind of do a similar thing where I say the quantity of my y-axis good, it'll start out with however much income I have divided by the price of that y-axis good. But now my slope will be the relative price of my x good over the price of my y good times the quantity of that x-axis good, right? When we're writing this out, we kind of have the general form of our equation here. We just flipped what the x good was and what the y good was. So now notice, if I wanted the slope of this curve, what should be the cost of one more can of PBR? It's that relative price of PBR to flannel shirts. So this would be what? 5 over 20, or negative 5 over 20, or sure enough, that same value of negative 1/4. Okay? So there's kind of different ways of thinking about how we're finding the slope of this budget constraint. Okay? Any questions? And I'm probably going even further than I really need to here, just kind of thinking about maybe how different ways of thinking about these budget constraints. Okay. Any questions on this? We're good? Okay. So with this in mind, this should be hopefully not too bad. We already did all of this on the slides, right? So let's go back to where I had flannel shirts on the, y-axis. I could start to think about what do these bundles represent? Well, if I'm at a point of 225, what's the total? Why do I know that point's underneath my budget constraint? Well, if I've got $200 of income, if I'm spending $20 in each flannel shirt, how much total have I spent here? 40. $5 in every can of PBR, I've spent 125. So the total amount of money I've spent is $165. That's less than my income. I know this point A would be a point that, yes, it's affordable, but I'm not using all of my income. What about this point of 8 and 8? Well, how much am I spending total on flannel shirts if I'm buying 8? 8 times 20 is 160. How much am I total am I spending on my y-axis good PBR? 5 times 8 is 40. Add those together, I'm spending exactly what my income is, $200. That's going to be a point that is on my budget constraint. And then what about this point of 530? 5 times 20 is 100. 30 times 5 is 150. So that'd be what? $250. I can't afford that point. That point will be past my budget constraint. Questions before we keep moving? All right, going through this a little bit quicker, but some of this other stuff I think we probably want to spend a little more time on. So what's going to happen to this budget constraint and the different combinations of these two goods I can afford if I see things change? So I've got some visuals on the slides, but I think it's probably beneficial for me to kind of build these out and kind of work from scratch here. So let's say, and let's see if I can remember this. I'll get them to switch. Oh, there we go. All right. let's say I've got, before I had flannel shirts on my x-axis, PBR on my y, so we were at 40. I didn't leave myself a lot of room here. Well, let me redraw this. So, flannel shirts, PBR, put 40 down here, 10 down here. Here is my original budget constraint. This was when I only had $200 of income. If I have $300 of income, just intuitively, what's going to happen to the different combinations of these two goods I can buy? It's going to increase. If I'm only buying good Y, how much can I now afford? Well, my income is now 300. The price is still 5. So what's the total amount I can afford? 300 over 5 or 60. What if I'm only buying flannel shirts? How much can I now afford? They're $20 a piece, 300 over 20. Now I tried to draw this to scale. Probably not perfect, right? But when I have more income, if I'm only buying good X or I'm only buying good Y, I can afford more of both, right? However, what's the slope of this line going to be? Now I can use the quantities to prove this to myself. So if I take, I'm going from 60 to 0, 0 to 15, I still get that same cost for a flannel shirt of 4 cans of PBR, right? My slope is -4. Well, what should the slope of my budget constraint always be? The price of that X good relative to the price of that Y good. What's the price of my X good here? 20. What's the price of my Y good? Hasn't changed. It's 5. So that's why if the prices don't change, I don't have any change in the slope of my budget constraint. It's just going to be this nice parallel shift. Now, why do we like that as consumers? If I have more money, I can afford to buy more of both of these goods if I wanted to. I could only buy more of this one, or I could only buy more of this one. But either way, I can now get to points that before were unaffordable and are now affordable, right? So shifts in increases income will allow us to get to these higher consumption bundles, more of kind of these two goods. What would a decrease in income do? Yeah, I could afford to buy less of both goods. Once again, prices haven't changed. So a decrease in my income would just be shifting that budget constraint down. Okay? Making what used to be affordable points no longer affordable. Okay? Questions on that idea before we keep moving here? Okay. So what if, and I think in the slides I got something slightly different, but we'll do this one first. So we kind of worked through all this. What's the next thing? Let's say the price of flannel shirts falls, right? So we'll start out in that same scenario where if I'm only buying PBR, I can afford 40, only buying flannel shirts, I can afford to buy 10. Let's say my income now hasn't changed at all. Neither has the price of PBR, but the price of flannel shirts has now fallen to 10. So just intuitively, if prices are now less or lower, what's happening to the value of my income? The real value of my income has went up. I can afford with the same amount of dollars to buy more units. Right? So if I'm only buying PBR here, what's the total amount I can now buy? Hasn't changed at all, right? The price of PBR is still $5. I can't afford to buy the same amount. However, if I'm buying flannel shirts, how many can I now afford to buy? Well, 200 divided by 10 would be 20. So when I have price decreases, that's going to kick out my budget constraint. Well, why do we like that as consumers? There are now points that before were unaffordable that I now can afford to buy. Okay? Now, before we had a slope of -4 here. I could use the quantities once again to find the slope, but remember, the slope is always going to be the relative price of good X to the price of good Y. What's my X good? Flannel shirt. So what is my new cost or the new slope of my budget constraint? 10 over 5 or -2, right? So when the price of that good went down, the cost of getting one more of that x-axis good has also went down. Think about why. Before, if I wanted one more flannel shirt, I was going to have to give up 4 cans of PBR. Now, if I want one more flannel shirt, how many cans of PBR am I going to have to give up? Just 2, right? Because that relative price changed, the cost of that x-axis good also changed. Any questions on this before we keep moving? So I think I have this kind of in the slides, just working through what we're working through here, right? We see kind of this kick out in our budget constraint. Now, I also did here, and we'll come back to the, oops, dot cam here in a second. We'll get all of these to be shown in the slides here. So A, this one will be easy. It should be easy. Represents a what? So if the slope of the line didn't change, but it shifted my budget constraint out, it was a what? A change in income. Not only a change, but an increase. We just worked through B. That was caused if I had a decrease in the price of my X good. What would C represent? Yeah, if I'm buying X, I can buy the same amount, so it's not a change in the price of the X good. But if I'm only buying Y, I can now buy more. It must have been the price of Y went down. Now, I don't have a picture of what happens if we get a price increase, but we can kind of think about what would happen. So let's say instead, we start out, original scenario, 40, 10, slope is -4, income was 200, price of PBR was 5, price of a flannel shirt was 20. Let's assume instead that the new price of PBR, I don't know, maybe I'm at like a game or something, it's going to be higher, right? So if the price goes up, intuitively, am I going to be able to afford more or less than I was before? Less, right? So there should be some points that used to be affordable that no longer are. So if I'm only buying flannel shirts, this price change did what? So if I'm only buying flannel shirts, price of PBR changes. If I'm only buying flannel shirts, I can still buy the exact same amount. Now, if I'm only buying PBR, what's happened to the amount that I can buy? Before I was buying 40, now 200 divided by 10, I can buy less, right? So there are now some points that used to be affordable before that I can no longer afford because of these higher prices. Now, what's going to happen to the slope here? Well, the slope is always the price of our X good relative to the price of our Y good. If the price of that X good stayed the same, but the price of our Y good went up, right? So our new kind of relative prices will be, not 5 over 10, sorry. Our X good was 20 over 10. My new slope is -2, right? So the flatter the slope, kind of the lower the cost. You can kind of think about why. To get one more flannel shirt, I used to have to give up 4 cans of PBR. Now to get one more flannel shirt, if PBR is now more expensive, I only have to give up 2. So these are kind of price changes, income changes. This is how it's going to impact our budget constraint. Now, we'll use this in the next class talking about substitution, income effects, kind of where the optimal point is. But we need to understand how these income and price changes are going to influence our budget constraint. I think it's fairly intuitive to kind of think about what's going on here. But we want to make sure we have this kind of down before we move on to the future topics. Okay. Any questions over anything I did here before we keep moving? Is this kind of making sense? Enough sense? I don't know. To me, this is a little bit easier than maybe what we were doing with externalities and things like that. So the next thing that we'll introduce, we now have this kind of concept and this idea of all these different consumption bundles, we'll call them, different combinations of these two goods that we can afford, right? But, you know, I don't only want to have just flannel shirts, right? Or I don't want to only have like whatever the good is, right? I want some combination of the two. Well, what combination is the best for me as a consumer? So the next thing that we're interested in, well, we're thinking about prices, right? And the trade-offs that existed. We also want to think about each of these goods might provide dramatically different benefits to consumers, right? So this new term that we're going to have that represents the benefit to consumers is what we call utility. If it helps, it's kind of synonymous with benefits, right? Total utility, total benefits to the consumer. Okay? So it's just going to be the benefits that are derived from the consumption of a good. Consumption bundles, I've already kind of accidentally used this term, but it's just a combination of any two goods, or really in theory, it could be the combination of all the goods that we're buying. Right? So we're going to use these kind of simple two good models. You can extend this to be 50, 100, 1,000 different products. Okay? The utility function is going to be some function that kind of is laying around behind the scenes. Now, we usually don't see it, right? But there is some function that says, as I consume more of something, what do you think is going to be happening to my total utility? My total utility goes down? Yeah, so if I have more of something, doesn't matter what it is, I'm going to have more. Now, what's happening to, you kind of jump the gun here, my total utility is increasing, but what about my marginal utility? So as I buy more and more of something, what's the additional benefit I receive from buying the next unit? It's going down. This was the same idea as diminishing marginal benefits. Now, even though we have diminishing marginal benefits or diminishing marginal utility, our total utility is still going up, even if it's by an infinitesimal amount, right? You know, even if I've got 100 bottles of water, that 100 bottle of water at some point is going to provide me some benefit. Not near as much as the first or the second or the third, right? It still has at least an infinitesimal amount of value to me, right? We can work through models where maybe marginal utility becomes negative. We'll end up seeing we'll never get to those points, so we usually don't talk about it. But for the sake of kind of starting out this discussion, let's think about as we buy more of something, the total utility is increasing. However, it's doing so at a decreasing rate, or the additional utility we get for every single unit starts to get smaller and smaller and smaller. Okay? So this idea, this term of marginal, we've already looked at marginal benefits, marginal costs. How do we calculate those? It's the change in the total divided by the change in the number of units we were buying or producing if we look at the old examples, right? So marginal utility is the change in total utility from a change in the number of units we're buying. Now, often we think about like just buying one more unit, but we can have examples where we say, you know, maybe the amount of units I buy has to go up by 5 or has to go up by 10. What's a good example of this? You know, you can't go to the store and buy, okay, maybe there's somewhere you can buy loose eggs. Like, I don't know where that, but you can't go buy one egg from Kroger, right? What do you have to buy them in? They might have half dozens, but mostly it's a dozen, right? If you want to go from having 12, even 18 eggs, I have to buy a second dozen eggs. I can only see these jumps in quantity that sometimes aren't one. Okay? So what's the marginal utility? It's the change in the total utility from a change in the number of units. So if I think about this, what this would look like visually from a table, and here I think my animation is set off, so we got all the information to us, but how would we get these marginal utility values? Well, if I wanted to go from 0 to 5 units, I'm increasing the number of units I buy by 5. How much was my total utility going up by? 60 units or 60, kind of however, you know, we don't really have a unit to utility. It's just for right now, it is what it is. Eventually we can put like $1. It's usually represented in dollars. But here, my change in total utility is 60. Change in the number of units was 5. 60 over 5 gives me that marginal utility of 12. What if I wanted the marginal utility of the 15th unit? Well, how would I come up with that 6? Well, if I want to go to the 15th unit, I have to go from 10 to 15. So my change in the quantity was 5. My total utility was going from 105 to 135. So that change in total utility was 30. 30 over 5, and it gives me that marginal utility of 6. So it's just like we were calculating marginal benefits or marginal costs. Sometimes we don't just have jumps of 1 unit, we have jumps of 5, 6, 12, sometimes 100. You're thinking about like large bulk orders that some of these big companies are going to make. they're not increasing the amount they're ordering from their supplier by 1 unit, right? They're asking for thousands, right? No one's going to supply. They're only going to give them like thousands, you know, these pallets of whatever product they're building. It might come and jump to the 1,000, right? So here's how we would calculate kind of marginal utility here. So just to get rid of, you know, what do we notice is happening to marginal utility? As we buy more of something, the marginal utility is declining. What's happening in total utility though? Still increasing. It's just doing so at a decreasing rate. So our marginal utility is diminishing just like our marginal benefits were. So I kind of left off an open slide. Let's say instead we had this idea of, this is my total utility. So this graph, I've got nice easy quantities here going 0, 1, 2, 3, 4. And here's the total utility that corresponds to each one of those quantities. So if I wanted to graph out my marginal utility, here I'm thinking about going from that quantity of 0, what would the marginal utility be of that first unit? Well, my quantity change of going from 0 to 1, what was the total utility changing by going from 0 to 1? Yeah, it went from 0 to 10. So my marginal utility would be 10. What about that second unit? Well, there, my total utility, I was going from 10 to 15. So my change in total utility from a change in quantity would have been 5 over 1. So my marginal utility there would be 5. What about the third unit? I'm going from 15 to, I think it's 18, or approximately 18. It's supposed to look like 18. So there, if I'm going from 15 to 18, my marginal utility would be 3. And then out that quantity of 4, I'm going from 18 to 20. So I've got this marginal utility of 2. So what's happening to this marginal utility? It's decreasing, right? Or it's diminishing. Same idea as we talked about with marginal benefits. Okay. So as I buy more of something, my marginal utility of that good is going down. Okay. Any questions on this before we keep moving? There we go. So that's kind of what we just did there. Left that slide open. So let's think about how consumers are going to make decisions. Okay. We now have this idea of how much we can afford. Different goods are going to provide us with different additional utility. So my goal as a consumer is to maximize my own utility. So another word like utility you can think of, utility represents the happiness of consumers. So when I buy things, I'm trying to maximize the total benefit to me, the total happiness that this consumption of these different goods will bring me. For some people, this might be buying a couple, you know, I don't know, classic cars, right? Or for some people, this might be, you know, buying a bunch of like, so, you know, I don't know, what's something that people like to collect? A bunch of baseball cards or something, right? Now that might not bring me any additional utility, right? So everyone's going to be a little bit different. So we're all trying to maximize our total utility, but we face these limited resources. So someone came into my office the other day and said, you know, I'm thinking about these ideas. What's you know, think of an artist or a musician that you love, right? Why don't you go out and get a signed version of like one of their, I don't know, limited edition albums? It's expensive. Costs you a lot of money, right? You only have a limited amount of resources. You likely can't afford it, right? Now, it would still bring you, if someone gave it to you, what would be the marginal utility that you would get from it? A lot, right? Still huge. But given your own income, given your own budget constraint, you can't afford it. So we can't just like buy as much as we want because we face these limited resources. We only have so much money in our pockets to buy, you know, these different goods. So we've already talked about this, right? We face this budget constraint given our income and given the current prices of goods. Now here I'm just using 2 goods just to kind of make it easy. But in reality, I've got a certain amount of money in my pocket. I go to the, you know, gas station. I can buy a bunch of different things, right? But I can only buy certain combinations. There's only so many I can afford. And sometimes I won't want to buy certain goods they have. I want to buy 2 or 3 of another one they have. So this is going to be kind of our goal. How do we choose what combination of these goods to buy in order to maximize our own utility, right? So this is the idea of optimal consumer choice. What combination of these goods is going to derive me the highest amount of total utility? So it seems kind of weird, but when we're making decisions about how to maximize total utility, what we actually use is the margin utility of these different goods. Okay. So when I'm thinking about if prices weren't an issue, what would I want to buy first? The thing that brings me the highest marginal utility, right? Whatever brings me the highest additional amount of utility, I want to buy that first, right? Now, as I buy more of that X good, what's happening to its marginal utility? So let's say, I don't know, I'm like stopping, I don't know why the gas station example is making sense today. Like I'm driving, I stop at a gas station, I want something to eat and drink, but I've only got a certain amount of money in my pocket. You know, I go in there, I'm like, okay, I'm really hungry. So the margin utility of getting something to eat is way greater than the margin utility of getting something to drink. So, you know, go in there and I get a, you know, candy bar, something like that. Well, now the margin utility of the second candy bar is going to be quite a bit lower, right? I've already kind of quenched my hunger. Now the margin utility of getting that first drink might be greater than the margin utility of that second candy bar. So maybe my consumption decision, maybe I was really way more hungry, so I bought the candy bar first, but then I switch over because that first energy drink or whatever it is I want to buy has a higher margin utility than the second candy bar. So this is the idea that we're kind of making our decision based on that margin utility. But in my example, I just ignored the fact that prices between these two goods may be dramatically different. If I go in there and candy bars cost $100, the margin utility I get, even though it's higher from a candy bar, I might still choose to just get something to drink, right? I can wait, right? So what is that idea? So that is the idea that prices matter, and we're actually going to make our decisions based off of the marginal utility we get per dollar we spend. So we're going to choose the good that gives us the highest bang for our buck, right? The highest amount of additional utility per dollar we're spending. So how do we do this? Let me see here. There we go. We're just going to be making decisions based off of marginal utility per dollar. How do I get it to be in a per dollar amount? I divide it by the price of the good, right? So whatever goods have a higher marginal utility per dollar divided by their price, I'll choose to buy that first, right? Now, as I buy more of that, what's going to happen to the prices? Nothing, but what's happening to the marginal utility of X as I buy more of it? It's going to go down. So even though initially I might start out, and let's say I buy one candy bar and one soda or whatever, because they have the same margin utility per dollar. Well, as I buy more of those goods, those margin utilities might be changing at different rates, right? They might be decreasing at different rates. So we're going to start to kind of factor this into our decision making. But for now, let's just think about, we want to consume up to the point, right? We're spending our money. We'll keep making decisions to buy whatever has the highest margin utility per dollar.
So the difference between marginal utility and marginal benefit, that marginal utility is divided by price.
So margin utility, we haven't factored in the price yet. This would represent the margin utility per dollar we spend. So if it helps to think about utility, it really is representing the same thing as benefits. The reason why we use this term of utility is the deeper you get into trying to understand consumer behaviors, there are things that are difficult to put dollar amounts on, right? So like equity, for example. People make decisions sometimes that don't make sense to us in our models, but that's because they like fairness. So they might give up so that somebody else can have something, because that brings them, yes, they're having fewer units, so it looks like their marginal benefit is going down, but the actual utility or happiness they get from everybody having kind of an equitable share, that's actually going to give them more happiness than losing out. So this idea of utility is more of that it's hard to really measure what the actual benefits are to people when they buy something. Because like you might think about, yeah, well, I buy something, I go to the store. Oh, what's a good example? Let's say I go to Kroger and I get like organic, I buy the organic corn. Well, it costs more money, right? And the benefit, it's honest to God, sometimes they label these things and they're coming from the same figures, right? So you might get the same additional benefit of eating it, but what additional benefit or whatever additional utility do you also get? this like feeling of like I'm doing a good thing for the environment. So we just use this utility because it kind of captures all the benefits that might exist to it. But if it helps to think about it, they really just means additional benefits. It's just that it captures all of these. Yeah. Any other questions here before we keep moving? Okay. So, and I don't know if that is true about organic corn. I've read things about like organic labels, and it basically you can kind of have back-to-back or fields right next to each other, which case they're both getting the same amount of pollutants. But I'm also not like that's not my field of expertise, so I should probably keep my mouth shut. So, I'm going to skip this for now. We'll probably revisit this just to start out discussion on Thursday. So let's think about if I actually were able to measure the marginal utility that existed from consuming two different goods. I'm thinking about how do we as consumers, how would we optimally make decisions? So I've got, excuse me, two goods here. So now I already forget. It's up there. What's the first column? Chips. So we went 0, 1, 2, 3, 4, 5. And then my marginal utility from chips was 18, was falling by 3. And then we had the quantity of soda here. Oh, I should have left myself a little more room. Marginal utility. So we had what? 0, 1, 2, 3, 4, 5, 6. And this starts out at 10. No, 12. Falls by 10. We got something like this. So we're not going to make our decisions based off of just the marginal utility. We want to make our decisions based off of what's bringing me the highest additional amount of utility per dollar I'm spending. So we'd actually want to calculate a new marginal utility per dollar that we're spending on chips. Now, here in my example, chips only cost $1. So what's going to be true about the marginal utility per dollar? If I divide the marginal utility by the price of 1, these all are the same exact values. However, if I'm thinking about the marginal utility per dollar of soda over here, it's the marginal utility if the price of soda is $2. I divide each of these by the price 2. What's my new marginal utility per dollar going to be? 6, 5, 4, 3, 2, 1. So now that I have this marginal utility per dollar, and I think the setup was we had income of $12. So I've got a total income I can spend of $12 going to the store, buying different combinations for my road trip, I guess, of chips and soda. So what's the very first thing I'm going to buy? Well, am I going to buy the first bag of chips or the first can of soda? What has the highest margin utility per dollar? That bag of chips. What about now? Well, buying the second bag of chips, the margin utility is falling. So the margin utility per dollar is also falling, right? Margin utility per dollar is just taking the margin utility over the price. So if the margin utility falls, so will the margin utility per dollar. Right? So now do I buy that second bag of chips or the first can of soda? Still, I choose to buy that second bag of chips. What about the third? What about the fourth? Well, now I get to this point. Would I buy the fifth bag of chips or the first can of soda? We would say consumers would be indifferent, right? So we would be equally as well off in terms of the margin utility per dollar if I buy either one. So let's say I buy that fifth bag of chips and then I buy that first can of soda. So I probably should have been doing a running total up to this point, but I kind of cheated because I know that we haven't spent all of our money. How much money total have I spent up to this point? 1, 2, 3, 4, $5. Each bag of chips is $1. How much have I spent on soda? 2. So the total amount of money I've spent is $7. So I've still got $5 to spend. Will I buy that sixth bag of chips or the second can of soda? Because so if we go back, we had the price of chips was $1. The price of soda was $2. So if I buy 1 can of soda, I've spent $2 there. So will I buy the sixth bag of chips or the second can of soda? Second can of soda, in which case I've now spent 9. Sixth bag of chips or the third can of soda. 4 is higher than 3. Now this is where sometimes when we get down to the end, we might have a little bit of like, we have to think a little bit harder about this. So if I look here, what would be true about the 6th bag of chips and the 4th can of soda? Consumers are indifferent, but can I afford that 4th can of soda? If I spend another $2, I went over my income, my budget constraint. So what, even though I'm indifferent, what would I have to choose here? That 6th bag of chips, right? Now I've spent all $12. This is where total utility should be maximum. You wanted to prove it to yourself. We won't like run through all this. If you were to add up all of the marginal utilities, right? You'll find that, well, if I add up all these marginal utilities, there's no other combination of these goods I could afford that would provide me with as high of a total utility as buying 6 bags of chips and 3 cans of soda could. And now how would I find total utility? Well, here, because we did jumps of quantity of 1, here, my marginal utility would just be what gets added into that total. So this would be kind of the process I use to make these optimal decisions about how much of each of these goods do I buy, right? I just kind of go back and forth, always choosing what gives me a highest margin utility per dollar I spend. Questions on this idea before we keep moving? Yeah.
So say like you still have the remaining, like, let's say like the quantity or the marginal utility was like 4 for that last unit, and you still have an extra dollar, would you be able to do anything with that?
I could buy the next bag of chips if I can't afford the other good. I won't probably ever set up an example where that is the case. And in practice, like we have a little bit more of a continuous kind of between these two goods of what you could buy. Well, yeah, sometimes we get stuck with like, we know the margin utility per dollar would be higher at that next good, but we can't afford it. Right? Now, this doesn't happen when there's not a big price differential. If I'm thinking about choosing like to make the decision between buying a soda and a burrito bowl where the price is much higher, there I might get stuck with some situations where I can't afford the other. Yep. So what if I had these exact same values or exact same, marginal utilities, but now I only have $8, right? And the price of both goods are 2. Well, I could still go through and solve this. What I would need to do is come up with a margin utility per dollar column for both of these goods, but then it would really just be the exact same process. So I'll kind of do this one a little bit quicker probably. So we've got 0, 1, 2, 3, 4. I know we're not going to make it down very far. What's the margin utility per dollar? So this was 18, 15, 12, or not per dollar, sorry, just the margin utility. I then can calculate the margin utility per dollar for chips. I have my quantity of soda, 0, 1, 2, 3, 4. Margin utility for soda was 12, 10, 8, 6. Margin utility per dollar of soda, we can calculate. So once again, if I now have that the price of chips is 2 and the price of soda is also 2, right? So my prices have changed from the previous example, and my income I have is 8. So what's the very first thing I'm going to buy? Well, what's the margin utility per dollar now for that first bag of chips? Yeah, I take the margin utility divided by the price of 2, 9. Here, 7.5, 6, 4.5. Over here for chips, well, it's the same thing we had before. The price is still 2. So when I divide margin utility by 2, I get 6, 5, 4, 3. So which of these goods am I going to choose to buy first? What has the highest margin utility per dollar from that first unit? So I buy a bag of chips. What do I buy second? Bag of chips. So I've spent what? A total of $4. What do I buy next? Well, here we're indifferent, so it doesn't matter which order I buy them in. I'll get that third bag of chips, the first can of soda. I've now spent all of my income. This is where I would stop. Right? So in theory, the last units of each good that I buy, the margin utility per dollar I spend should be the same. Right? In theory, those two values should be the same. We said we can get to this scenario where, given my income constraints and that I don't truly have like a perfectly continuous jumps in quantity, I get them to be very close, right? Where at least the very last decision I was making, the margin utility per dollar was the same for both. It might be that I can't afford both, but that decision I was making at the last margin utility per dollar, these two values were exactly the same. Okay. Any questions over this process here, kind of what we're talking about? All right, let me think what I want to do here. I don't think it makes sense to spend as much time on that. We can start with there. So we can run back to this idea because I think it's interesting. And then maybe we'll look at some questions here. So this idea of buying something that provides the highest margin utility per dollar, I think it goes back to my earlier example that I was using about like the signed album or whatever. And it's always kind of set up. This might even be an example that they reference in the textbook, but it's this paradox of value, right? So if we think about the total utility of water versus the total utility of diamonds, right? If I think about the total utility that water is bringing me, probably pretty large, right? It's allowing me to live, right? So the total utility I derive, of all the water that I own, say in a year, or I buy in a year, really high total utility. Now, diamonds, they provide me with some utility, right? Not near as much as something that sustains my life. So we know that inherently the total utility that a diamond will bring me is not near as much as the water I can consume over the next year. However, if we think about the marginal utility, well, what's the marginal utility that first diamond brings me? Pretty high, right? It has a pretty high benefit to me, makes me really happy. That's assuming you like diamonds. If you don't like diamonds, choose your, I don't know, accessory of choice. Like maybe you want like the sickest Rolex or whatever, whatever your accessory of choice is, right? It would bring you a high amount of additional marginal utility. However, right, that first bottle of water, what's the marginal utility I'm really getting from drinking this right now? That's letting me talk a little bit more clear to you guys. It's helping me not faint in front of you, but it's not like the largest marginal utility, right? So we have this idea where we have this kind of outcome where the marginal utility of a good can be relatively low, right? But if we're consuming a lot of it, the total utility it can derive us is quite a bit higher, right? So we kind of end up with, well, how do we equate this then with our decision making? If I know that the marginal utility of water is relatively low, but that I must be buying a lot of it because the total utility is relatively high, what has to be true about its price? It must be pretty low, right? So we can have, as long as we have something that has a low marginal utility, as long as its price is also low, we can see that consumers choose to buy a lot more water over the course of a year than they do diamonds, right? So all of you, I'm guessing, I don't know all your backgrounds, I guess when I was a college student, I purchased a lot more water than 0 diamonds, right? So this is the idea that when the prices are relatively low, yeah, the marginal utility from that good might be low, but you're going to end up buying a lot of it because the marginal utility per dollar is also really, really low. I think another good example of this to me, especially like even as a college student, like if you have a car, gas kind of gives you the freedom to go do things, right? So the marginal utility of an extra gallon of gas is pretty high, right? And the price is relatively low compared to other things. So you probably buy a lot more gas over the course of the year than you do airplane tickets. Airplane tickets might allow you to go to some place that brings you a whole bunch of additional utility, huge marginal utility because you have to go travel to New York or something like that. What's also true about the price of that airline ticket? It's pretty high, right? So we can end up with these goods where we have low marginal utility, but also low prices. We still see people, the total utility they derive, they buy a lot of it, right? And that's because we make decisions based off of the margin utility per dollar we spend, right? So even though there's these things out there that, yes, would provide us with a high amount of margin utility, the margin utility per dollar is relatively low, right? I told someone to stop by my office yesterday, but my wife and I are going to the Taylor Swift concert. And while I think it'll be fun, and the margin utility might be high today, the price of those tickets is also very high, right? So if I was making the decision based off of the margin utility per dollar, I might not have chose to go to that concert. But I also derive a lot of utility from my wife being happy. So there you go, right? So let's think about going back a little bit. And this is where I'll stop this so that being